Hi, welcome to Minijack. Today we are going to look at something slightly more complex with the matrix mixer. It's actually proper synthesis. We have two square wave oscillators, are basically LFOs, are very low frequencies. As you can see from the blinking, is very slow, is not audible frequency. I mean, we can actually listen to that sound, which is just a clicking. Now we are listening to this one. Now to the faster one, because we can actually only hear the edge of the square going down, going up and going down. And here we have a little digital oscilloscope, which is connected to this black patch cable. So whatever I want to see what's the first oscillator is doing, I can check it by connecting it here or here for the second. And then here we have a graphic equalizer. Is a very nice vintage, I'd say, graphic equalizer. It has 10 bands. It's an active equalizer, meaning that on the zero level is actually 0 decibels. What comes in comes out, and then you can actually amplify any frequency you want, one of the 10 frequency bands, up to 12, which I think is supposed to be 12 decibels. It's pretty loud. Or you can attenuate to a pretty low volume, the same frequencies. And here we have the usual Big Muff PI. It's an overdrive. It's basically a clipping device. It cuts anything that goes higher than a certain level. It works with diodes. And yeah, the oscillators are wired to the matrix mixer. We have the two outputs of the oscillators that go in the two first channels, so we can listen to the first one or the second one. But in the output of the first two channels of the matrix mixer, we actually have voltage control over the same oscillators. So we can send a voltage control that can actually come from an audio signal or one of the two voltage controls. For example, if I assign the first oscillator to the second, it will control the speed, and we have this kind of rhythm, because when this goes up, the second one goes faster for a short period of time. And here what we can see is like tak tak, 2 by 2. And yeah, that's how it works basically. And then in the control voltage input of the two oscillators, you can actually feed almost anything. The range is almost 10 volts. Here in the oscilloscope, we I don't know if you can really see, every square is 5 volts. So these peaks we are seeing at the moment are almost 10 volts, like 9.5, something like that. And so not all audio signals are up to that voltage, so they're not modulating the full speed. Here I also have manual knobs for the speed. They can go really slow like this, or audio range, up to audio range really high. It sounds a bit glitchy because it's actually an LFO, so it's not made for audio frequencies, but they can do it. Well, I think that's it, and I have the usual lexicon reverb unit. The output from the matrix mixer is fed into this normal mixer, because what I wanted to do is I have those stackable cables, so I just duplicated my output and I have it the same signal running in two channels. In one of the two channels, the first, I have the bass all the way up, and I am cutting highs and mids, and the opposite on the second, I cut the lows. Actually, I can use, oh yeah, it was on the low cut, so it just completely kills the bass. And sometimes I choose to have all mids or all highs. And this channel I am sending to the reverb as a wet effects, and I have the return here because I want some depth, some reverb, but with the very low sounds you're going to hear. For example, that's the basic triggering of oscillation, for example. So that's 62 Hertz, works very well. If I, and now we are listening to this one, to the graphic equalizer, I trigger the feedback, and that's pretty loud. Yeah. Distorts even. Now it's better, yeah. I don't want these to be fed through the reverb because it will just saturate that and mask all other frequencies, but I can sometimes kick in the high part of the sound, and it's nice. For example, if I add the clicking, it's nice. So that's the way it's gonna be. And of course, I thought I have one more slot in my Matrix mixer. So actually the return of the reverb in my main mixer as a double cable here, as you can see. So one of the two channels of the return is wired to another channel in my Matrix mixer, and everything is buffered. My Matrix mixer is buffered, so you can actually connect up to 5 or 6, depends on the power supply outputs, and it won't attenuate or ruin the signal. And so yeah, here we have a basic feedback path for the reverb. That's just reverb feeding back, and as you can see, it doesn't feed back if I put up the volume in the low part, because it's everything in the low part, but it kicks in pretty violently. Yeah. And yeah, I think that's it. The basic idea. Now I will show you different patches. I took some notes in my fancy patch sheets. I always ship my mixers with some patch sheets. It's always nice to have the possibility to write something down, even if there is not always the possibility to reproduce exactly what you did, and that's also the beauty of analog equipment and electronics music. But yeah, the main idea that is at the base of almost all the patches I will show you is the graphic equalizer feeding back on itself and creating a bass or high sound, depends, but usually that's the bass, like this one. And if I inject one of the oscillators, for example this one, the first one, the very slow one, in the feedback path, what happens is this. Because the oscillator sound is actually a DC voltage. Every peak you see here is a DC bias, so it's saturating the feedback loop. So in that brief moment where the oscillator is high, we cannot hear sound, and that's the rhythm. It's very basic, but yeah. And of course we have two oscillators. We can simply inject two of them in the path, and we have a composite rhythm, which is just depends on the individual speeds I am putting here, so it can be an infinite loop, never going to match. But another thing we can do is, for example, the first oscillator modulating the second. So we have a more regular rhythm. We can always have a look at the waveform. It's like, yeah, what you're hearing and what you're seeing is really self-explanatory. And well, that's it. Let's take a look at some patches. I will comment on some of them and enjoy. We have simply the two oscillators running almost independently. There is a little bit of cross-modulation that gives us the larger intervals between the impulses, the highs, and they are both fed in different amounts in the feedback path, and I chose some frequencies to have this mid-bass sound. And in this patch I am actually doubling the bass from the mixer, and I also have some highs for the clicking sound. That's what goes into the high-cut channel. We can modulate the high part. That was a filter. It is basically a bunch of filters in parallel. And we can create variations and poses, for example fitting some of the oscillators in one of the paths of the feedback of the equalizer or the distortion pedal, for example. Like this, we are going to listen to only one of the two loops. Fit the same here. We hear the other. This we hear both. Can kind of control the pitch, feeding more of the reverb coming from there, which is in this case the bass, back into the equalizer. And that's a very simple rhythmic patch. That's it. In this patch I am basically controlling the two blocks of cross-modulation. The first one is between the two oscillators, which is those four knobs. Those other four knobs are basically the interaction between the distortion pedal and the equalizer. And for example here I made this. When they overlap there is kind of a syncope. So when I have the bass is gated to the rhythm of the two oscillators. Here you have the low part, here I have the high part. This patch is quite interesting. It starts from a concept that came from a friend of mine. Ciao Biera, thanks for that. And he said, well, why don't put everything to the maximum, connect everything in the matrix, and then work subtracting. So why not? Then that what happens. Of course, when everything is on, all the signals are saturated and we hear just this buzz. It's basically silence. And then, for example, we start subtracting things from the main cross-modulation of the oscillators. That's what we want to unlock, basically. You can listen to different parts of the signal path from here. Here we are all flat, but here we can kind of shape the sound of the click. Okay, here we have some basic feedback from the graphic equalizer, which is just a note. And then we have in the cross-modulation corner, we are just creating this rhythm pattern. We inject that into the feedback loop. Signal present, it doesn't feedback. When it does feedback, there is no signal. In this one, I'm using the distortion pedal, which clips the signal above a certain threshold, kind of, to shape my one of my control voltages. So the first control voltage goes out to the distortion, comes back in, and does modulate the second one, and that's what we get. The second one is, but yeah, it's easier. We use it directly to modulate some feedback from the usual graphic equalizer. And in this case I am only listening to the mids, because the bass is just rubbish. The signals from this analog synthesis is always very rich in harmonics, highs and lows, so you always need one or more filters to select what you want to hear or what you want to not hear, basically. And you can put some reverb in the loop.
if we feed this one back into the second oscillator.
equalizer. You can hear that the low end is pointless. Just hear the high part. And here we can create some very basic bass drum sound. We are using this oscillator as a main clock, and it's just feeding into the equalizer. I put the frequency at 62, is the one that works best. Is the one of the lowest, but is not the lowest, so we can actually hear it. And that's a very basic sound. And when we put up the feedback, there's a point where it starts feeding back. That's too much, and we go back a little bit. Until we have this nice roll-off. And that's because the feedback doesn't cut immediately, but it has a small envelope, volume envelope, once it receives the clock. In this patch, I'm basically controlling the second oscillator with the first. So as we can see, is a pretty regular pattern, but with some variations in length. And the sound is created by always the equalizer feeding back to itself. But we can create these very delicate tom-like sounds using multiple frequencies instead of only one. Is usually a tone or a bass. We can carefully choose the frequencies and the amount of each frequency. And for example, we can feed some of the sound into the distortion and try to feed it back into, for example, the equalizer. So we can morph from a tom sound to more harsh sound. Send some distorted audio to oscillators. And well, that's it. And what's interesting about these oscillators is that they output basically clock signals. So you can use this signal, maybe you can buffer it, and it's possible to use it as a clock, for example, for another modular system, or with a little converter, digital converter, even to MIDI. So it's really open to expansion. And those were just a little selection of examples of sounds that you can create with a matrix mixer and this setup. And of course you cannot do it with a passive matrix mixer, because it needs the signal needs to be boosted and isolated from inputs to outputs, and my matrix mixer are all provided with a buffer, input and output buffers. So that's why you can feed any number of signals on every single channel, and you can use every single channel to output channel to pilot how many outputs you'd like. And well, that's it. If you like this video, do not forget to give me a thumbs up and subscribe to the channel to stay tuned for more videos. And if you're interested in a custom matrix mixer, just send me an email. I will put all the details down in the comments. And yeah, see you next time.